Hello, today I will show you homework 3.1 to you. It's about Arduino and serial. Okay, you can see the title of this research is Arduino serial motor control with I2C LCD display. So you can see the experiment overview. The goal is serial control plus visual feedback, and the scope, hardware code, and debugging. This presentation walks through an Arduino-based control demo that continuously sweep a standard 118 serial between 0 to 118. Severely, uh, I2C LCD displays the current angle in real time, and the serial monitor prints the angle for debugging purpose. The experiment objects, the core goal is use an Arduino to precisely control a serial motor's angle and visualize the current angle on an I2C 1602 LCD while outputting the same angle via serial for debugging. The measurable outcomes have three parts. First one is smooth motion, and second is clean display, and the third one is data consistency. Okay, why this matter? The learning value, mastering the fundamentals of the embedded control through the classic actor to plus display combination, and the several library mystery. We need this understand how the Arduino abstract complex PWM single generation into single angle comments and I2C bus efficiently. Learn to use the 2-wire I2C patrol for LCDs and saving valuable GPIO pins compared to the parallel interface. And the hardware value I forget to put in this PPT. So wait a minute, I will show you my exhibition video. So we need the Arduino board and the serial motor and the LCD display and the power. We can see the component pin VCC to the Arduino pin 5V and the ground to ground. SDA to the A4 pins, and the ACU to the A5 pins, and the VCC to the 5V. Okay, so the code structure. The program followed a standard Arduino architecture, but introduced a modeling approach for display updates. The high-level structure consists of global configuration and hardware initialization and continuum main control loop. Okay, so you can firstly see um, the library and the initialization code. The library will input several .h and this liquid crystal I2C .h. Then the setup function runs once and stop. You can first see the startup function, the several achievements, the LCD preparation, and the static UI layout, and the serial debugging. So the main loop function, the serial sweep logic. The first one is speed up. For loop increment the angle variable from 0 to 118. 80 in each interaction. My several dot white angle current to the angle into the specific PWM duty cycle sent to the serial signal pin, and the real-time feedback. Inside the loop, we call update LCD as LCD immediately after setting the serial position. Similarly, serial dot pins in log the angle. This ensures the visual display is always with the physical movement, and the phase 2 is swept down. Once 118 is reached, a second loop reverses the direction. It decrements the angle variable back to the zero. This creates the reciprocation scanning moving typical of radar or vapor application. So the display logic, you can see, target updates is clear. Instead of using LCD.clear, we use LCD.set cursor to overwrite only the changing number area. This creates a professional, stable display. And the ghost digit problem. LCD character persists until overwritten. If you display 118 and then 9 without handing, the screen would show the 918. This is a common bug in Bagger embedded project. So you can see the implementation flow, the power on and set up to the sweep 0 to 180 and to the sweep 180 to 0. Then the last one verify output. And you can see the technological insights and tips. The pin select and I2C address several scanner requires PWM pins. For Mega, I2C is on pins SDA and SCL 20 and 21. Default I2C LCD addressing is usually 0 multiply 27, but 0 multiply 3F is common for some clones. You can see the signal integrity and motion smoothness. Okay, so the last one is summary. When we achieve implemented smooth 0 to 180 to 0 save wave control via Arduino loop logic and virtuously real-time angle on an I2C LCD without screen flickering or residuary decays, and established a robust control feedback loop using serial monitor for debugging. And the key takeaways: library, we need several .H and PWM and so on. And then the I2C efficiency, using I2C saves for digital pins to correctly for complete project and the UI logic. Then we extension to try. Okay, now we can see the examination.
我觉得娃子今天的感觉圈儿吧是比去年的简单很多的，简单点我都会做，正好 PLC。
You can see the hardware connection and the serial monitor.
You should mess out.
没有，买了哦，真的。
啊？有蒸蛋？
对啊。
我操！
吃了2万多蒸蛋，挺好吃的。
不跟二上传了。
嗯。
You can see the changes of the angle. Okay, that's all for this homework. Thank you.